So what if we have an equation and we decide that we want to try to take the square root of both sides, or the cube root or the fourth root, but for us it'll usually be the square root of both sides. Well, if we were to do that this way, we would think that this would be x plus 1, and we would think that this would be 2. We'd subtract 1 from both sides, and we'd get x equals 1, and we would try it out, and we'd put a 1 in here, and 1 plus 1 is 2, and 2 to the second power is 4, and this checks, and we'd be happy with ourselves. The problem is, there's another solution that we did not find. Can you see that x equals negative 3 is also a solution? If you put in a negative 3 right there, negative 3 plus 1 is negative 2, and negative 2 times itself is 4, and we missed that solution altogether. So when you take the square root of both sides, you'll most likely be missing a solution unless you remember a small trick. To take the square root of both sides, if we're going to call this left-hand side 1, x plus 1, if we're going to say that the square here and the square rooting undid each other, then on the other side, the number side, we have to put in a plus or minus before the square root. So we have x plus 1 equals plus or minus the square root of 4, which is 2. Now what does this mean? Well, we can take away 1 from both sides, and we have x equals negative 1 plus or minus 2. So x equals negative 1 plus 2, or x equals negative 1 minus 2. Negative 1 plus 2 is 1, and negative 1 minus 2 is negative 3. And you can see when we use the plus or minus, we still get the equation, the solution that we would have got if we had just done it thoughtlessly. But we also get the other solution, the negative 3. And so don't forget, when you're taking the square root of both sides of an equation, put a plus or minus in front of the numerical side, the non-variable side. When you're taking the cube root of both sides, you don't need to bother. So what are we going to do to both sides here? Well, we've got something squared equals negative 7, so we're going to take the square root of both sides, and we're going to put a plus or minus in front of this side. Since we've put the plus or minus, we can then declare that the square root of this squared is x plus 3. And then we have plus or minus the square root of negative 7, but that's the square root of 7 times I. We know that little trick about negative square roots. We're going to take away 3 from both sides. On the right-hand side, put the minus 3 in front of the plus or minus. These are not like terms. They're not going to combine, so this is a really good way to leave the answer. If you don't like it, you can write it out this way. X could be this, or X could be this, either way. So you can write it out separately, which takes a lot more work, or you can write it out in one compact statement. Notice this is two solutions. It's negative 3 plus the square root of 7i, and separately it's negative 3 minus the square root of 7i. So here we'd like to use our square root of both sides idea to solve this equation, but before we do that, we got to make sure we have a perfect square. So we're going to do something for the first time in this course called completing the square, and we're going to use it a fair amount in the next few weeks, so try to get used to it. In this particular problem, we're going to add 3 to both sides and leave a blank space here. So we've added 3 to both sides. This is an equivalent equation to the one above. It has the same solutions, but we're now going to complete the square. The idea is we want to add something here, and of course we'll have to add the same thing over here to keep it balanced. But we're going to add something here that makes this trinomial be a perfect square, something times itself. So we would like it to be something times itself, like x plus something, x plus something, or x minus something, x minus something. And the way to do this that will always work is you go to the coefficient of the x term, which is 8, you cut it in half, you divide it by 2, which is 4, and then you multiply that by itself, which is 16. You always do that, and so this is going to be 16. And now you simply factor this. How's it going to factor? Well, it's going to be 4 times 4. Because this gives you x squared, this gives you plus 16, 4x plus 4x gives you 8x, and we've made the left-hand side be a perfect square. But we had to add 16, so we got to add 16 over here. So now we have x plus 4 quantity squared equals 19. And now we do the steps that we did in the previous problem. We're going to take the square root of both sides. We're going to put in the plus or minus to catch both solutions. The square root of something squared in this case can be called x plus 4. 19 does not have any parts. If you try to do the prime factorization, there's no matching parts in there. So we take away 4 from both sides and we get x equals -4 plus or minus the square root of 19. And we're just done. Let's try another one. Let's try to solve this by completing the square. So we subtract 5 from both sides. We make room to add the same thing to both sides. We go to the coefficient of x. It's 2. We divide it by 2. That's 1. We multiply that by itself. That's 1. So we're going to add 1 to both sides. And here we get x plus 1 times x plus 1. It was a perfect square. Here we get -4. So we have x plus 1 squared equals -4. We take the square root of both sides. We remember to put a plus or minus in. We have x plus 1 equals plus or minus, and this is the square root of 4 times I. Subtracting 1 from both sides, we have x equals -1 plus or minus. This square root of 4 is 2, and we have 2i. And so we have two solutions, x equals -1 plus 2i, and x equals -1 minus